picking off where we left off yesterday, we're going to be just walking through developing, trying to advance the slide. Okay. Creating a CMS project. So we'll be loading different bathymetric scatter sets. Well, I think we did a lot of that yesterday, working with different datums. Today we'll be moving beyond that. Now that we have that scatter set, developing a grid domain and identifying the activity of the domain as either land, which will be the inactive, and water, which is the active computational space. Okay, so where we were left off. Also, we are tracking participation this week. Okay, that's a note from it. So we've already had the different scatter sets from yesterday all brought in, and we merged them, and that's where we left off. And you can see those in the data tree here. And we've just unchecked those, and a note here that you can remove them from your data tree. However, do note that if you save the project once those files are no longer visible in the data tree, that means they will be no longer saved in your project. So as we talked about yesterday, there is no undo button. So what I like to do is not only save frequently and often, but save in new file locations. So if I'm working on a project, I may create a new folder and directory once I've done a major step through the process. So for example, once now we have all of these merge scatter sets, you could create a new file directory to save the project with just the merge, so that way that when you save that, you still can go back to your old project directory where all the individual scatter sets are. And I apologize, I have a cough drop in my mouth just because I'm also getting over a cold. Okay, so moving on from that, now you can see the data tree is clear, and that will help as we add more area properties to the map and other elements in the data tree. Okay, so next we'll add some new coverages for CMS, and these are the specific model elements that will go into our CMS flow simulation. So that will include a coverage for the boundary conditions, a generic coverage called activity classification. And that's a really vague name, but I like to remember what that means as setting the domain as either active or inactive. So it's the literal activity of the computational space that we're setting, that we're classifying. And then depending on whether or not we want a telescoping quadtree or a Cartesian, which is uniform, rectilinear or square, not necessarily square, grid, you can choose either a generic quadtree generator or a generic C-grid generator, which stands for that Cartesian grid. And to do that, we right-click on map data and say new coverage. It'll pull up these coverage types as either generic or different models. So different models have different coverages, as you can see. For CMS Flow, this is actually, I think, an outdated image. We have additional activity coverages or area properties, but we must have for every simulation a boundary condition. So we'll start with that. So now you can see in the document tree, we have a boundary condition file. So now we'll add the activity classification, which is a generic coverage. And so that and the quadtree generator have both been added. And you can see that in the data tree now. Okay, since we're going to be jumping back and forth between different map coverages, as you can see here, we have 4 at least, and sometimes it can be difficult to tell whether or not they're in the data tree or not, necessarily that they aren't or are in the data tree, but switching between them back and forth can be easier when we can see them. So what we can do is go to our display options and click this box here for inactive coverage, and that will allow us to see all of our coverages at once to make sure they overlap or they are where they are or aren't where they're supposed to be. And there's a little icon here that you can look for that is the shortcut for display options. Although you can go from atop the menu and right click display, and that will give the drop down for display options. Okay, so moving on, we're going to start by selecting the quad tree or C-grid generator coverage, whichever you are actively working in. And then we will select this Create Grid Frame tool. So you can see it's right here. This is the active toolbar that changes dynamically depending on what we are working in, whether it's a scatter, a map data, a certain kind of map data. So this is the symbol of the grid frame generator tool. So to define our domain for CMS Grid, we'll click 3 points that are generally around the area that we're trying to model. So you don't have to be super particular about the order that you click these in, although it will kind of automatically propagate a right angle. So you can kind of just start with a general definition of your boundary space, and that will begin to create a grid frame. However, sometimes it can be a little difficult to see the entire grid frame. So the difference between the previous slide and this slide is that we made our contour semi-transparent. And I think that was one of the features that the display options that we played around with yesterday. So now that our contours, our scatter contours are transparent, we can see the bound of our quad tree generator grid frame. So now to edit that grid frame, we can select the grid frame tool. We can select the select grid frame tool, which is the grid frame image, that purple square with the little pointer in the middle. So once we do that, we will see this middle square pop up, and that's always in the center of your grid frame. So that allows you to highlight it. It's just a polygon to click on as opposed to trying to click on a certain line. And once we have that highlighted, you can see we can edit the size of this like you would edit a picture size in Word. And this circle here in the bottom right-hand side portion of this figure is this little circle, and you can use that to toggle and rotate the axis handle. So the domain is going to be split into X and Y, and the positions of those X and Y coordinates are defined in I and J space. So that's why you'll see I and J in some of these images and informational slides. Again, a reminder to continue saving frequently as you go along. Okay. So if we know exactly where we want our domain to be, for example, if it's overlapping with an existing wave grid or fitting within the bounds of another model, we can double click the grid frame selector, which is that square in the middle, and it'll bring up this property dialog. So after you play with the handles a little bit, you can then actually prescribe very specific boundary conditions. For example, if you're working through these exercises yourself, you can define the actual angle to be what you want it to be and the size of the full grid. So the I size is the width across the whole X section, and the J size is the length of the full Y dimension. Down here, we have I cell and J cell options, and that's the resolution of the grid in X and Y space. And we'll get a little bit into this in a minute because there are some nuances because we're working with a quad tree generator, which means that we'll have variable grid cell size. And again, we'll come back to that. Okay, next we'll define the land-water interface for the activity classification coverage. And we'll do that by clicking on the activity classification coverage in the data tree. So you can see that that is bolded and highlighted in the data tree. And when we right-click that, oh, excuse me, what we actually do is, what we're going to do is we're going to create the actual polygons that define the activity classification. So the activity classification, as you see now on this figure, it doesn't exist. This layer that we're working on, this active layer, will have the properties of an activity classification, but we have to actually make the bounds of where we want to define water and land. So to do that, we're going to leverage the information that we have in the scatter set. And these are the steps that we take to do that. So what we can do is from the data set, the scatter data set, extract a contour that represents an elevation boundary that we care about. And that elevation boundary is one way we can define active and inactive coverage, as opposed to guessing where we think the water may or may not go, if that makes sense. So to do this, you right-click the final bathymetry dataset in the scatter module, and you'll say convert, and then that will pop up with some options that are helpful for different circumstances. So I encourage you to explore those. But in particular, we care about the scatter contours to map. So you can see, looking at the data tree, we're going to take information from the scatter and we have to convert it to a map feature so that it will show up in our activity classification. So that's what we're doing here. Okay, now we can define the destination coverage. So we've identified it to take the information from the scatter set and particularly convert it to activity classification. You can also do this if you wanted to, for example, create quad tree generator polygons. And we'll get to that in a minute, but that's just to say you can define different destination coverages that all have different advantages. Okay, so what we're going to do is define the elevation of the contour that we care about. So the contour that we care about, for example, in this context, is going to be the mean sea level. And this is just a rough estimate. You wouldn't always use 0.0 that contour as the bounds of your active domain. You might want to consider the tidal range. So thinking about, if you know you're going to have wetting and drying in your model, you might want your active coverage to extend at least a few meters, or whatever the vertical tidal range would be, above mean sea level to define as your active coverage boundary, plus or minus a little bit. But for the edification here, we simply have defined 0 as the elevation that we care about, and the spacing along this contour, that means the points along which this polyline that we're going to create, what's the spacing going to be like? If that was a really large number, we might get a really coarse contour, and then if that's a really small number, we get a more refined contour. So once we do that, this is the contour that we get from the scatter set. So we have this lovely polyline here, and it has all these points that defined the features of our modeling space. Now, when we do this, and we can do this a couple of times. So for example, maybe you want to add another little polyline that goes, excuse me, got to point with my pointer, further around, or maybe you create a few different contours and then splice them together to be your active boundary area. So now that we've exported those or converted those into the map, we now need to make a single line that will be easy to form the bounds of a polygon that we can then click and set as active or inactive. So we often have to clean up this polyline, and that's the steps that we're going through here. So we click these feature arc selection tools, and what you can do is click these arcs or polylines, or I guess polylines are technically a different feature, but I sometimes accidentally use them and arcs interchangeably. However, these are really arcs. So we can click these arcs and remove them. You can continue to do this throughout the entire domain. And if you are actively clicking on multiple arcs that you want to remove, but want to avoid using your cursor to remove what you have selected, but still pan through the screen, you can use the F2 key. That's just a little hot tip. So if you want to sometimes create a new arc in between a few points, so for example, if you want to make this one continuous arc and avoid just, maybe you don't want to delete the whole arc, but just a few points, you can select this vertex selection tool, and that will allow you to select these individual small points. Now, one thing that's maybe going to come up, but there's a difference between vertices and nodes. So nodes are what connect different arcs together, and arcs are made up of individual vertices. And there's different selector features for that. So what you can do is select the vertices that you want to get rid of, delete them, say yes, and then I think there's a setting that will either automatically connect your new points or not. I think that's default, but you may be able to turn that off. Another way to bring in a shoreline or some way to define the boundary between the active and inactive coverage is with something like the coastline database from NOVA. So what you can do is go to your region of interest, which for us is Shark River Inlet, and say, I'd like this CUSP data product, which is not necessarily for, well, maybe that is for CUSP 8 features, but I think that's just the name of the data product. But anyway, we can tell it what we want. It will extract that for us by rectangle or by region. We can select the type, continually updated shoreline project. Thank you, Mitch. That's what CUSP stands for. And select the format we want that in, either a shapefile, a KML, whatever. And then voila, we have a CUSP data product or a shoreline that we can use to then bring into our model, and that will help us define the active coverage area. Okay, so to do that, we can see that we've brought this in either via drag and drop, or we can go to up here, our main menu, and say File, open a shapefile. So you can see that we've already done that. And then once we bring that in, to convert a GIS data to map, what we can do is say convert shape to feature object, and then say, okay, we have to tell SMS exactly where we want this new feature object to go. So we tell it, put it on the quadtree generator, which of course you could also do this for the activity classification. And then do you want to map it and select the number of shapefiles you're interested in mapping. There we go. We've moved it to the activity classification. And then if there's any kind of elevation associated with that shapefile, we can either retain that information, and these across the top will let us define whether or not we want to map that to an X or Y position, or whether that's just simply a name that we don't necessarily care about. For us, for the purpose of the activity classification, it's not super important that it has an elevation associated with it, because the the point of this activity classification exercise is to just define a polygon that is the active or inactive portion of the domain. So when we're done, we hit finish, and voila, another way to bring in a shoreline. Okay, next up, create the polygon with the coastlines to determine and define the inactive or land area of the domain. So to do that, we have to have a polygon. So what we can do is create another arc with the Create Arc tool here, and we simply click from one edge of our shoreline feature to the other, but doing so in a way that allows us to retain some kind of volume so that you can see what we've done here. So now up at the top, we will go to Feature Objects, Build Polygons. So that's what this step is here. Feature Objects, Build Polygons. And then once we do that, we're able to click in the middle of this polygon and right-click it to bring up the, that's how we can select a polygon. Make sure you're working in the active Select Polygon tool. And so when we right-click that, it'll bring up the attributes. So that's what this little pop-up shows us. And we can set that as active or inactive. The default will be inactive because most commonly what we're doing is we don't necessarily need to set an active area, but we want to basically block out the computational nodes and cells that we don't want to be taking up computational space where we have to go in and, the code is going through and putting 0, 0, 0s or nans for all of these points. So this is just a way of basically putting a mask over them and say, don't even worry about these cells. So that's how the activity classification works. I have a note here that you really only want to do this to perpetually dry areas. These are areas that you're positive are never supposed to experience wetting and drying over the period that you're trying to simulate. So for example, this island feature in the middle, although we do have a contour around it because that was generated by the scatter contour generator. So even though that area or that line corresponds to 0, meaning the area in the middle, you can see it has a lower depth, meaning higher elevation. That's kind of like an island in the middle of this inlet. And there might be circumstances where you want that to be inactive and you're positive, for example, if there's this is unrealistic, but some building or structure in the middle of your inlet. You would say, yes, positive, there's never going to be water within the bounds of this island. However, wetting and drying over the tidal cycle might enable water to reach that area, that elevation. So you might want to check to make sure that area is not inactive. So if it's a full polygon, make sure you double click all the solid areas to make sure that none of the areas that you intend to be active have accidentally been set to inactive by default. Okay, but moving on, nothing has to be exact right now. We can set some more of these properties that I'm talking about, inactive and inactive and active, once we have the Cartesian grid constructed. So this is a good point to stop and save your project. If you're going through the files with us, we've now completed up to workshop day 2 and then part 2 after coastline.